There you go.
All right, here we go. So for this do now, it was just a review of finding the vertices and positive and negative intervals, which we've done before in here. This one, the vertex is down here, that's +3, -4. Over here, my vertex is at -1, 1. Then the zeros are just the places where it crosses the x-axis. So here we're crossing my x-axis at x is 1 and at x is 5. Over here, my zeros are -2 and 0. And then what is a positive versus a negative interval? That's a throwback from a couple of weeks ago. What does positive mean, Trey?
Isn't positive like above the x-axis?
Above the x-axis. So here, this chunk here and this chunk here are above the x-axis. Over here, it's this little guy right there. So how would we write those intervals?
Negative infinity to +1.
Negative infinity to +1. Good, so it comes in from the left, stops being positive here at 1, and picks up again at
+5 and infinity.
+5 to infinity. Good? For this one, my positive interval is this little tiny chunk from -2 to 0.
Are you sure that's -2?
Yes.
It's symmetry.
-2 to 0. And then if it's not positive, it is negative, so that's this part here below the x-axis, which is from 1 to 5. Over here, the negative pieces are from negative infinity to -2, and from 0 to infinity. You remember that?
Yes.
Pretty much. Okay. So just to recap, from yesterday, what does the vertex form equation look like?
A parentheses x minus h whole squared
X minus h squared
plus k.
plus k. And then the h and the k give you the vertex of your parabola. Standard form equation we remember from forever ago, y equals ax squared plus bx plus c. So our goal today is to practice going back and forth between those two. Now when we're finding zeros, aka solving an equation, we've been working with really 3 different methods. What were they?
Computing the square, factoring, and the
Completing
quadratic formula.
the square, factoring, and quadratic formula. So anytime you're asked to find a zero, really you could use any one of those methods. Today we're going to stick with completing the square simply because we already have to complete the square to get the vertex form equation, and then you're halfway done with your problem anyway, so we'll just use that method to solve.
Okay.
And as Trey reminded us earlier, positive intervals are the ones that are above the x-axis. Negative intervals are the ones that are below. So up until now, your problems have been something like the do now, where I give you the graph and then you can find the positive and negative intervals, you can find domain and range and what have you. Today, we're going to take it one step farther, where instead of me giving you the graph, all I give you is the equation. And then you use what we've been learning this week to find the vertex and the zeros, and then you can find out information about the graph based on that. So example number 1, we are given y equals x squared minus 8x plus 15. Justin, what's my first step gonna be if I want to complete the square? Not for completing the square. What do I need to do with this guy?
Oh, put to the other side.
Put it to the other side. So I'm subtracting 15 from both sides. We get y minus 15 is equal to x squared minus 8x. And then Nick, what do I need to add to both sides?
Add to both sides?
To make this into a perfect square.
Oh. Don't you have to do like the b divided by
Mhm.
2?
So b divided by 2 is
4?
4, and 4 squared is
16?
16. So we're adding 16 to both sides. That gives us y plus 1. And then this is now a perfect square. We'll factor into x minus 4 quantity squared. So now we're done completing the square. And this is where we are going to branch out, because we're going to use this completed square for two different things. Thing one is going to be finding the vertex, and thing two is going to be finding the zeros. So to find the vertex, we need vertex form equation, which means y needs to be by itself. So we subtract 1 from both sides of the equation, and we get y is equal to x minus 4 quantity squared minus 1. So that's vertex form equation. And now what's my vertex itself going to be?
Isn't it 4 negative 1?
4, change the sign, negative 1 stays as is. So when I go over here to graph it, I know that the vertex of my parabola is going to be right there at 4, negative 1.
That's the vertex. Right?
That's the vertex. Now step 2 means we need to find the zeros. What exactly is 0?
Y.
I'm proud.
Like, yeah, when y equals 0, right?
Y equals 0, the y value. So I'm going to take this completed equation here and say y equals 0. If y is equal to 0, all we're left with is that 1 is equal to x minus 4 squared. So what are we going to do to solve for x?
Multiply by x minus 1, right?
Not multiply,
Square 1.
square root. So we have this square up here, square root.
That makes more sense.
Square root of 1 is conveniently a whole number. This is plus or minus 1. The square root and the squared sign cancel each other out, and we are left with x minus 4. And to solve for x, adding 4 to both sides. So we have 4 plus or minus 1 equals x.
Wait, no. Oh, yeah, you're right.
So 4 plus 1 gives us 5. 4 minus 1 gives us 3. So my zeros are at x equals 5 or at x equals 3.
Does it have to be accurate, like the drawn or no?
As long as it has those 3 points accurately.
Okay.
Yeah.
Okay, so why up there when you were solving for zeros, did you get rid of the y?
Because what is y equal to when we have a 0?
Oh, okay.
Y is equal to 0, so it falls out. So we have 3 points here. That's enough to see what the shape of my parabola is, yes? So if we connect these, little whoop, right through there, something like that. Now that we have a graph, we can find those positive and negative intervals. So this is positive above the x-axis, this part here, and this part here. So my intervals are from negative infinity to 3. Then it dips below and again at 5 to infinity. It's negative below the x-axis, this little section in here, which is from x is 3 to x is 5.